Hello, this presentation is about turning landfill gases into energy by David Zimmerman for Environmental Management 501, American Military University, Professor Dr. Emily Kushto. Here is an outline of what will be covered in this presentation, including project location, vision statement, project scope, management alternatives, success criteria, summary, and references. Here is a satellite image courtesy of Google Maps of the project location. Our vision is to turn yesterday's trash into tomorrow's clean energy that will not only power the Savannah community, but will reduce greenhouse gas and climate change around the world. This project sets out to convert the active and inactive landfill sites into landfill gas collection facilities. The landfill gas will then be sent to an on-site power station to be converted to electricity. Now to cover the management alternatives. There are several alternatives to choose from throughout this project to achieve desired outcomes, or if there is an increased environmental impact that was unexpected. The variable options are changing the flaring system, choosing different water treatment options, and increasing engine efficiency with a combined system. The management alternative that was chosen for this project is using a combined heat and power system to increase engine efficiency. Internal combustion engines are efficient at converting landfill gas into electricity, but even greater efficiencies are achieved in combined heat and power (CHP) applications, where waste heat is recovered from the engine cooling system or exhaust to make low-pressure steam or hot water. This can be sent to nearby industrial sites that can use it for space heating, domestic hot water heating, cooling, or other industrial processes, according to the EPA 2019. Also, according to EPA 2019, almost two-thirds of the energy is wasted by heat loss using engines used to generate electricity, but by incorporating the two technologies together, the efficiency can go from 30 to 40%, up to about 80%. According to BEAT 2011, when collecting the heat from an internal combustion engine and using it to heat air, an efficiency of up to 95% could be achieved. The first application of this would be installing a system at the landfill facilities to produce hot water that can be used for heating, cooling, and hot water needs at the project's different buildings. In addition, in evaluating the area, the landfill shares a border with Port Logistics Group, a warehousing and logistics service with a 360,000 square foot warehouse. This is a great option to use the captured heat to produce hot water that could be used to heat and cool the warehouse area with an absorption chiller. With the warehouse proximity to the landfill, it would be an efficient and environmentally friendly use of this energy to further reducing fossil fuel reliance for heating and energy to climate control the large warehouse. Success criteria. Overall success is achieved when all areas of landfill have a well within a year of the waste cell being closed, and the collection efficiency is measured at 75%, according to the EPA 2020. The project manager and site superintendents will ensure that wells are installed within the first year after capping the landfill site. The collection efficiency will be measured by comparing the landfill gas collection wells gas reading with parameter and well cap measurements. The project also sets out to reduce greenhouse gas by capturing the methane released from decomposing trash in the Savannah Dean Forest landfill. Determining the success criteria of this goal will be measured when the release of the landfill gas is at less than 1.5% by volume of methane, and CO2 is less than also 1.5% by volume. Surface and methane emissions will be read by pulling readings from a site cap in other areas of the landfill to see how much methane and CO2 is being released. This project's energy goal is using landfill gas as fuel to an internal combustion engine to power a generator that will supply the power to the grid managed by Georgia Power. Success will be measured by reaching a target energy production as of 3 megawatts an hour. Georgia Power, that owns the power grid, will provide weekly reports on the amount of energy produced from the project. In addition, this project sets out to provide hot water to Port Logistics Group for their climate control needs of the 360,000 square foot warehouse. Success will be measured by the reliance on the hot water supply by the landfill and no supplemental heating or cooling needed for the warehouse. In closing, this presentation covered the project scope, vision statement, management alternatives, and success criteria. Please see the list of references used in preparing this presentation. Thank you for your time.